space. The final frontier, vast, dark, and seemingly peaceful. But this tranquility is an illusion. The universe is violent, filled with forces beyond our comprehension. Stars are born and die in cataclysmic explosions. Black holes roam, and unimaginable energies are unleashed every second. We worry about visible dangers. Asteroids, cosmic impacts. We track them, prepare for them. But what about the invisible threats? The ones that arrive as waves of pure energy, not solid objects. These silent threats come from our own sun, the star that gives us life. We take its steady presence for granted. But the sun is a boiling ball of plasma, a nuclear reactor with moods and tantrums. When the sun lashes out, it can cripple our modern civilization. Scientists at NASA are only now beginning to grasp the true danger from our star. The greatest threats don't announce themselves. They travel silently across space, unseen and unheard. These are solar storms, one of the most significant yet least understood dangers to our technology-dependent world. For years, we thought we understood their power. We built models, made predictions, and felt secure. But recent discoveries have shattered those assumptions, revealing a hidden power that leaves us more vulnerable than ever. The silent threat is not so silent anymore. We are in a race against time to understand it. The universe is not a quiet neighbor. Our sun is not as gentle as we believed, and the next solar storm could change everything. What is a solar storm? Imagine the sun as a turbulent ocean of superheated plasma driven by powerful magnetic fields. Sometimes these fields snap, releasing colossal energy, a solar flare, a flash of radiation reaching Earth in minutes. But often, that's just the start. The same explosion can hurl a massive cloud of plasma, a coronal mass ejection or CME, into space. If Earth is in its path, it's like standing before a cosmic cannon. Our planet's magnetic field usually shields us, creating beautiful auroras. But a powerful CME can overwhelm this shield, letting high-energy particles rain into our atmosphere. The real danger isn't to life, but to our technology. Satellites, power grids, and everything that runs on electricity. A solar storm can trigger a cascade of failures, plunging us into darkness, even if only for a while. For decades, we watched the sun from afar, building models to predict how solar storms would behave. We assumed these storms would weaken as they traveled to Earth like a smoke ring dissipating across a room. Our defenses, satellite shielding, grid protocols, were built on this belief. Data from near-Earth instruments seemed to confirm our theories. We felt confident, even complacent, thinking a truly devastating storm was unlikely, but all our knowledge was secondhand. We'd never sampled the solar wind close to its source. It was like trying to understand a hurricane from satellite images, never flying into the storm itself. Our models were based on assumptions, not direct evidence. We thought we understood the giant in our backyard. But science is about challenging assumptions, and soon, those assumptions would be shattered. Enter the Parker Solar Probe, NASA's daring mission to fly through the sun's outer atmosphere. Launched in 2018, it was built to withstand unimaginable heat and radiation, to sample the solar wind at its source. What it found stunned scientists. The solar wind near the sun was chaotic, turbulent, and far more energetic than expected. Instead of a smooth flow, Parker flew through a cosmic storm of violent energy spikes and magnetic whiplashes. The old smoke ring analogy was wrong. The solar wind wasn't losing energy, it was being actively energized. Focused jets of power, not a dissipating cloud, were racing toward Earth. This was a paradigm shift. Our models weren't just off, they were fundamentally flawed. Solar storms weren't weakening as they traveled, they were retaining their destructive power. The threat was not diminished by distance, it was hidden, waiting to strike. The Parker probe revealed a sun more violent and unpredictable than we ever imagined. Our understanding of space weather was upended. The storms arriving at Earth could be far stronger than we thought. The silent threat was now a roaring danger. We had to rethink everything, and fast. The Parker probe's key discovery? Magnetic switchbacks. Instead of smooth magnetic fields, Parker found violent kinks, S-shaped folds that whip back and forth. These switchbacks are like sudden rapids in a river, accelerating solar wind particles to higher speeds. They inject energy into the solar wind, keeping storms strong across millions of miles. CMEs aren't uniform clouds. They're riddled with these energetic structures, reinforcing the storm's power. The result? Storms arrive at Earth as complex systems of high-energy jets, far more effective at overwhelming our defenses. A moderate storm could carry the punch of a severe one, hidden within these switchbacks. The impact is sharper, more damaging, and much harder to predict. This isn't just theory. We've seen solar storms disrupt our world before. In 1989, A solar storm knocked out Quebec's power grid in minutes, plunging 6 million people into darkness. Satellites are also at risk. Storms can damage electronics, disrupt GPS, and force satellites out of orbit. The ultimate warning comes from history, the 1859 Carrington event, the most powerful storm ever recorded. Auroras lit up the skies as far south as Cuba. Telegraph systems sparked and caught fire. If a Carrington-level event hit today, it could cripple power grids for weeks, destroy satellites, and cost trillions. Our society is far more dependent on technology now. And with NASA's new discoveries, we know storms can be even stronger than we feared. The risk of a superstorm causing unprecedented chaos is real. It's not a question of if, but when. The sun's next tantrum could change everything. Are we ready? The clock is ticking. The Parker Solar Probe's discoveries are a call to action, not despair. Now we can build better defenses. More accurate forecasts, more robust technology. With improved models we can predict not just when a storm is coming but how severe it will be. More warning time means power grids can brace for impact, satellites can be protected, and flights can be rerouted. Our shield is information and preparedness. The sun is still powerful and unpredictable, but it's no longer as mysterious. We're learning its secrets, forging a shield of knowledge. The silent threat from above is being watched. Because we're watching, we can be ready. The next solar storm won't catch us by surprise.